So here we have a hollow circular cylinder. So now first thing first is, what do you understand by this? So we have a hollow, it means it is open at one end. So let me draw something to help us with this question. So here we have a cylinder. On top it is open. And then at the bottom, I think it is closed. Because it tells you here it is open at one end. So I guess this here it is closed and open on top. So this is what is the shape. This is the shape of a cylinder. We have to know this for math questions, unfortunately. Now, it is constructed of thin sheet metal, okay? The total external surface area of the cylinder is 192 pi this. So the external surface area. Okay, good. So what can we think of right now is how would you find the surface area or the total external surface area of the cylinder? Let's observe. According to what we have right here, we can see that the TSA, which is the total surface area, is equal to what? It is the area of the curved surface, so curved surface area, and then plus the area of the circle area at the base. Because the top it is open, we don't have the top, we only have the base. So this will be equal to my total surface area of this cylinder. Okay, so let's first use that. So we know this is equal to 192 given to you by the question. So let's write this down. We have 192 pi is equal to the curved surface area. We have to know this formula. That will be 2 pi RH, and then plus the area of the circle at the base. So area of a circle is pi r square. So now we have just to replace and try to solve this step by step. So here we have 192 pi is equal to 2 pi r, the radius, I don't think we know anything right now. The radius we don't know, and h we don't know as well. Very interesting. So there's many things we don't know in this question. So let's see what is the first thing we can do. Let me just continue for now. Let's see what can we do about this. So first thing we can do is let's cancel out pi, because we have pi here, and pi here. We can just cancel out pi on everyone. So right now you will have 192 2 RH plus r square. Now, because here I only have an h, we can try to make this become the subject. So you have 2RH is equal to 192 minus r square. Now h will be 192 minus r square divided by 2r. For now I have this. Now again, you might ask me, hey, how do you know you have to do this? The answer is I don't know. I am just trying to make an equation from what I can see. That's the main thing. Because here to make r become the subject, it will be kind of hard. So let me just make h become the subject. So the thing is that I don't really know exactly what to do. That's not, I know the question sometimes is, hey, how do you know you can do this? I don't know. I just proceed logically to see which one is the easiest way to do something. So for now I have this. Now again, I can always change that afterwards, but for now I have this as my equation number 1 derived from the given information. That is part 1. Now part 1 of the question itself, we have to express h in terms of r and show that the volume V is given by this. So you can see we have actually to use this h in terms of r, that is the first part here, and we have to show the volume is equal to this. Now, how do you find the volume of a cylinder? It is equal to pi r square h. So this is something we have to know for the volume of a cylinder. That will become pi is pi, r square is r square, and h we have seen here it is equal to 192 minus r square over the value of 2r. Simplify, let's see what do we have. So this and this will cancel out, so you will have pi r 192 times r square divided by the value of 2. So let me rewrite this down so we can have exactly shown as required. So let me send the r inside. You will have half is here, pi is here. Now we send the r inside. You will have 192 r minus r cubed. That will be the value for v. That will be part 1 of the question shown as required. Now again, I think this was just sheer luck that we had to do this, but as you can see, we always use the given information and proceed step by step and see what is the easiest way we can do or express something in something else. Now it just happened that here we have to do h in terms of r, and then we have to solve this to find this shown as required. Now for part 2, we are given that r can vary. So r is the radius can change in this equation. Now part 2, we have to find the value of r in which v has a stationary value. Now we know what? We always have to know at the stationary value, what do we have? Value, we have to have what? dv. So v has a stationary value, so dv by dr has to be 0. So we have to know this. Because as you can see here, the equation of v, it is in terms of r, and r vary. So we have to have dv over dr is equal to 0. This is what happens at the stationary value. Okay, so let's write this down. For part 2, we have this equation that we have to use, which is this. So part 2, we have v is equal to half pi 192 minus r cubed as required. This is r here. Don't forget this one, very important. Now, we have to find dv by dr. Pretty easy, differentiation. Now this one is only a multiple, we can just put this ahead and forget about this. Now on the inside, what is dv by dr of 192r? That will be 192. And then here we have to first send the power over here, that will be 3. And then r3 minus 1 is 2. So this will be dv by dr. Now we understand that at the stationary value, dv by dr is equal to 0, so we have to equate that to 0. So let's proceed. Now we can just send this over here, so cross multiply, for example. So 2 goes to 0, that will be 0. So we have pi 192 minus 3r squared is equal to, so because we have sent the 2 up here, because if you think it is pi times 192 minus this over 2, right, is equal to 0. Now if you cross multiply, 2 times 0 will be 0. So that's why we have 0 here. Now, because we have this, we can divide by pi on both sides. So this will cancel out. You will have this 3r squared is equal to 0. Now what else can we have? We can have, make this become subject, that will become 3r squared is equal to 192, and r squared will be what? 192 divided by 3, that will be 64. So finally, r is the radius, that will be root of 64, that should be 8 as your answer. So here the value of r was required, so we have r is equal to 8, and that will be centimeters for the unit. As you can see, we were able to proceed step by step. We used the previous answer here to find dv by dr and equate that to 0, because we know that we have to know this at the stationary value. This will be always the truth. Okay, and then using that, we have to solve one by one to find the value of r. Now for part 3, we have to find the stationary value and determine the nature. So pretty easy. So let me continue here. So the value itself is what? The value, the maximum or the minimum value of v, or the stationary value. We just have to replace the value of r we found in the main equation. So here we have half pi, that'll be 192, r is 8 minus 60, that will be, 8 power 3. Here we don't have 3. My apologies. I have used the wrong equation. We have to use this one. 192 times 8 minus r cubed. 8 power 3. That'll be half. That will be what? 192 times 8 minus 8 power 3. That will be 1024. Then divide by 2. That will be 512 pi as your answer for the volume of this cylinder at its stationary value. Now, of course, we have to simplify this. Times pi, that will be 1608.459. Now, if the value is not exact, we have to try to write this down correct to 3SF. That will be 1610, and then that's it. This will be your answer for part 1 here of the question. Now we have to also find the nature of this value. So pretty easy. To find the nature, we have to use d2v by dl2. So we have to find the second derivative of this one. So we know that dv by dr is this. We have to differentiate that one more time. Let's see what do we get. So half pi is only a multiple, that will be outside. And on the inside, this will become 0. It is a constant, and then that will become 6r as your value. Now that will become cancel out, that will be 3. That will become minus 3r pi, or minus 3 pi r will be the value of this. Now because r is 8, replace here, you will have minus, so 3 times 8 will be minus 24 pi. So here we have this. We realize this is a negative value. So since, you would say, since d2v, or the second derivative, is a negative value, we know that the stationary value of v, which was found to be this, value of v is a maximum value. So that's the main idea here. So once you find out this is negative, it means it is a maximum value. If it was positive, it will be a minimum value. So we have to know this for this kind of finding the nature problem. So this will be a question involving the rate of change and how can we use the concepts that we have learned to find the following values. As you can see, it is not very hard. We just have to be careful with the steps and step by step moving on to find the required values for this question.